Okay, so I'm recording now, and let me share with you guys the review. So actually, I'm going to share a couple of things first. I'm actually going to share the formula sheet first. So let me double check. Yeah, it looks like you guys can see this part. So this part, let's see, this part here we've seen before. This is the same kind of formula sheet that we've always done. Yeah. The part, because somebody did ask, what about the sort of new formulas? And so I'm going to bring that down here. So just to give you a heads up, I mean, this is like how we find the confidence interval, but a lot of times I was showing you guys how to do that on the calculator. But like here's how we find our z-score, or the t-score, or the z-score for proportions. And here we go. So this was like the little, I called this the little cheat sheet, but I kept using this a lot in my videos recently for like chapter 7 and 8, because I found like looking at this, to me, this is super helpful. And so when I'm doing the problems, guys, you see I pull it up because to me, having this is like really, really critical. A lot of, I'm not going to say that these formulas here, let me kind of scroll back up. I'm not going to say that these formulas here are useless, but I can do a lot of this stuff on my calculator, and so I don't necessarily need a formula. I'm providing them for you in case you kind excuse me, you kind of do it the old school way or whatever, and that's perfectly fine. But if you excuse me, if you like using the calculator, then a lot of these formulas you don't necessarily need to know. I mean, we still were doing the z-score, t-score, and z-score for proportions. But we can do that on the calculator, but having this right here was like super, super critical for me. Yeah. Excuse me. So just giving you a heads up, this is a formula sheet for the final. So let me stop sharing this part, and I am going to share the review itself. Let's see, here we go. This is it, I think. Yes. Okay, so guys, really what I wanted to do tonight was ask you all, what questions did you have for me so that I can go over them tonight and we can see, what kind of issues you might have had or whatever, and we can try to clear those things up. So if there's a particular question you have, you let me know. I'm happy to go over that, guys. And it looks like there's just two of us tonight, so 2 or 3 of us tonight. So
I actually wanted to comment on that. I saw a few people in the course review area. I'm not sure if they're confused where exactly to go, but
I'm sorry.
I originally joined in on the first option of the review session, which was the course review. And I saw several other people.
Oh, there was people there?
Yeah.
Okay. So let me go ahead and check them out. Let me see the course room. Let me make sure, see if there's anybody in here. Let's see. Yes, you know what? They actually are. So let me make sure that they can see me too. So you know what? Let me take a picture of that.
Okay.
Okay. Thank you so much for letting me know.
Yeah, no problem.
Okay. So let's see. Okay, thank you. Let's see. Let me see. So, Laura and Maribel, I don't know if y'all can hear me. Um, so, guys, give me 1 second. Okay, Maribel is coming in. Excellent. And let's see if Laura's coming in. Okay, good. Maribel is here. All right. Okay, so let me see. I'm trying to see if anybody else is coming in here. Guys, I'm going to just log out of this session so I can get Laura to come to the other one. So give me one. Okay, excellent, great, perfect. Okay, great. Everybody's here now. Excellent. Okay, perfect, guys. So let me go ahead and share the review again with y'all. So let's go ahead and go through that. Okay, and let me make sure that everybody can see it. Yes, perfect. Looks like it's coming through. Okay, so again, guys, remember in the excuse me, in the announcement that I sent out through Blackboard, and then in our, I think it's in our week 15 folder, the formula sheet is there. So I did pull that up for you guys so you guys can see that. And so you have the formula sheet. Again, I was just going through that real quickly. You know what, let me share that one more time just so that we can, for those of you who just got here, we can see that part, because I do really want to emphasize this right here. And excellent. Okay. So guys, I wanted to mention that this part right here of the formula sheet to me is super critical, because it makes it, it just makes it easier for me to understand. So this whole part right here, all of this here was just really helpful for me when I'm doing my hypothesis testing, you know. So once I figure out if I'm going to reject or fail to reject, then I have to obviously go back and say, okay, which was my claim, all that kind of stuff, right? So anyway, I just wanted to say this part was really, really helpful for me. So I hope it is for you all as well. And all of this stuff here is in our formula sheet. Okay, so all this stuff is here. This is the last part of it, but I just kind of wanted to mention that. So let me go ahead and come back to the share the review. And really what I wanted to do tonight, y'all, was whatever questions you all had for me, I wanted to answer them. Okay, so if there's any questions that you have, if you know, like, oh, there's a particular question that I know I had a question on this one, speak up, guys. This is what I'm doing tonight. This is what we're here for. Okay.
Could we do question 16, please?
Of course. So let's go to number 16. I'm just going to scroll down, guys. So if it's going kind of fast, I'm just trying to move down to it. And let's take a look at number 16. Here we go. Okay. So let's see. Here we go. Okay, so it says use the normal distribution of SAT critical reading scores for which the mean is 509 and the standard deviation is 114. Assume the variable X is normally distributed. And it says what percent of the SAT scores are less than 550? Okay. So let me grab my pen real quick. Here we go. All right. And so we know that the mean is 509, and we know our standard deviation is 114. So what we want to do is we want to convert this to a z-score. So what we're looking for here is what's the probability that X is less than 550? So what we're going to do is we're going to convert this to a z-score. So our formula is X minus mu over sigma, okay? And so my X score in this case is 550. So I'm going to put 550 here. Our mean is 509. And our standard deviation is 114. Okay. So let's do this part. Let me just get my calculator here, guys. So the first thing I'm going to do the top part. I'm going to say, what is 550 minus 509? And I'm coming up with 41 over 114. Okay. And I'm just going to divide that out. 41 divided by, 114. And so I'm coming up with, I'm going to round this to 2 decimal places. So guys, on my calculator, I came up with 0.3596. So if I go to 2 decimal places, I would write 0.36. So I'm going to get here 0.36. So now, so the next part I'm going to do here is, since we were looking for the probability that X was less than 550, and we converted this to a z-score, that's saying the same thing as what's the probability that Z is less than 0.36, okay? So if I were to think about this as the normal curve, okay? So say here's 0, 0.36 is going to be right about here. And because we're looking for less than, we're looking for the area to the left. Okay? So if I wanted to do this on my calculator, the way I would do this is I would find the normal CDF. And I want us to think about this. So here's my x-axis, right? And we're coming all the way over here to the left. So wouldn't we say that all the way over here to the left, we usually use like a negative 9999? And then we're going to stop at a 0.36. So let me show you how I'm going to do this on my calculator so y'all can see. And here we go. Okay, so I want to say that, there we go, you can see the calculator now. So I'm going to go second bars, and I'm going to go down to my normal CDF, which is number 2. And we said we're going to go from negative 9999 to comma 0.36. And so right here, and guys, for these numbers, we usually go to 4 decimal places. So I would probably put something like 0.6406. If I'm going to round this to 4 decimal places, 0.6406. So let me stop sharing this and let me go back to the review. Okay. And we came up with something like 0.406. So I want you to notice something here. This here, guys, is, let me get my pen working. There we go. This here is a decimal. So if you notice here, it says, what is my answer going to be as a percent? So if I'm going to move this to, if I'm going to change this to a percent, I just got to move this 2 spaces over. So 64, so right here, I would write 64.06 would be my answer for part A. Okay. Now that we have that, part B says, well, what happens if we had 1,000 people, 1,000 SAT verbal, 1,000 SAT verbal scores are randomly selected. How many would we expect to be greater than 525? Okay, so now we're going to do a second problem. Okay, so I'm going to go through this problem the same way. So if you notice right here, it says greater than 525. So we're looking for what's the probability that X is greater than 525. Oops, 525. Okay, so we're going to convert this to a z-score. So here's my formula again. And we're going to say, okay, let's take 525 minus our mu. If you remember from the previous, from part A, guys, our mu was 509 over our standard deviation, which was 114. Okay. So let me go ahead and do this part here on my calculator. I'm just going to grab my calculator that I got here with me at my desk. Let me clear this out. 525 minus 509. That's given me a 16 over 114. And I'm going to go ahead and convert that to a decimal. So let me divide it by 114. And again, I'm going to round this to 2 decimal places. And guys, what I'm coming up with is 0.14. Okay, so now what we're trying to figure out is what's the probability that Z, since this here had greater than, we're going to put greater than 0.14. Okay. So again, if I draw my picture, here's my picture. Here's 0. 0.14, it's going to be pretty close to it. And because we're looking for when it's going to be greater than, we're looking for the area to the right. So if I were to think about this, same way we did before on our calculator, I would say I'm going to use my normal CDF, but I want you to notice my lower limit is now 0.14, and because we're going to the right, this is going to be 9999. So I'm going to do it just like I did before, guys. If it's okay with y'all, I'm just going to do this here on my calculator. I'm going to go to normal CDF. My lower limit is a 0.14. My upper limit is a 4 nines. And I am coming up with, to 4 decimal places, probability that Z is greater than 0.14. I am coming up with 0.4443. Okay. All right, so we got this part of it done, but it's actually telling me what happens if we had 1,000 SAT scores. How many of them would be greater than? So what I'm going to do now is I'm going to take 1,000 and I'm going to multiply it by that 0.443. And so if I multiply this number by 1,000, I'm coming up with approximately 444.
Great, thank you.
You're welcome. Does that make sense?
Yeah.
Excellent. Great, great. Very good. Very good. All right. So, guys, any other questions that you all need help with? Like I said, guys, this is really what I want to do tonight. I want to answer as many questions as I can. I want to make sure that you guys feel ready for, I'm looking up here. I have a little dry erase board that I screwed into my wall. So you guys can either take the test Monday night or Tuesday morning. I just want to make sure that you guys feel good for either Monday night or Tuesday morning, whichever one you decide to do. Any other questions that I can help you with, guys? Don't be shy. This is why I'm here.
I also needed help on, I mean, if there's no one else.
Yeah, ask me.
Question 21.
Of course. Let's go to 21. And let's see. Okay. Okay, excellent. Yeah, so it says, this is perfect. It says you're given a sample mean and a population standard deviation. It says use this information to construct both the 90% and the 95% confidence intervals for the population mean. Okay, for the population mean. Okay, it says interpret the results and compare the widths of the confidence intervals. And it says if convenient, let's use some technology to construct these confidence intervals. Okay, perfect. When we're actually going to do that, guys. So I'm looking here and it says we have a sample of 55 home theater systems. Okay, that's telling me that right now that my N is 55 and that has a mean price of 141. So my X bar is going to be 141. And it says assume that the population standard deviation is 1930. So my sigma is going to be 1930. Okay, so what I want to do here is I want to show you, using our calculator, we can find both the 90% and the 95% confidence intervals. Okay, so guys, what I'm going to do, I'm going to use this information here on my calculator, okay? So let me stop sharing this part here and let me pull up my calculator because I want y'all to be able to see how I'm doing this. Guys, one thing I do want to mention is whether I'm using my calculator or that calculator app that I use when I make the videos on my iPad, the process is going to be the same, okay? So let me stop sharing this part and let me share my calculator. And let me turn it back on. There we go. Okay, so I'm just going to clear this out, and I'm going to pull up the problem so I can see it again. Okay, so first I'm going to do, I'm going to go to Stat, and I'm going to go over to Tests, and we are doing a confidence interval with Z's. So we're going to go to Z interval right here. Okay, number 7. I'm going to hit Enter, and we don't want to go to Data. We want to go to Stats. So I'm going to go over here to Stats. And let's, oops, stats, enter, there we go. Okay, so my sigma should be 1930, so 1930. My X bar we said was 141, and my N we said was 55, and my confidence interval, I think the first time we're doing a 95% confidence interval, so I'm just going to put 0.90, and then I'm going to go down to calculate, and I'm going to hit enter, and here is my numbers. Okay, so we have 136.72 to 145.28. So I'm just going to write those numbers in, and I'll come back and we'll do the second part. So 136.72 and 145.28. And guys, I'm going to do this process all over again because we also want to do one for the 95% confidence interval. So I'm going to go to Stat. I'm going to go back to Tests. I'm going to go back to the Z interval test. And the only thing that I'm going to do is I'm going to change this right here from a C level of 0.9. I'm going to change it to 0.95. Okay, and go over to calculate, and now we have a new one. So I have 135.9 and 146.1. So 135.9 and 146.1. Okay, so let me stop sharing the calculator and let me share the review again so that you guys can see what I'm writing down here. And let's see, I want to make sure that you guys can see it. Yes, perfect. Okay, so now, now we have 3 choices. It says interpret the results. So part A says with 90% confidence, it can be said the population mean price lies in the first interval. With 95% confidence, it can be said the population mean price lies in the second interval. And the 95% confidence interval is wider than the 90, okay? So again, guys, remember what we're looking for. Just to give you a heads up here, we're finding confidence intervals for the population mean, right? for the population mean. So one thing I want to mention is when I look at choice A and it mentions population mean price, and I look at choice B and it mentions population mean price, I like those choices better than I like choice C, because choice C says sample mean price, and we're not looking for the, we're constructing confidence intervals for the population mean. So if I see sample mean, that already tells me, okay, you know what, that's not a good one. Okay, so now we've narrowed it down to two choices. It's either going to be A or B. So now we want to figure out which interval is wider. Is the 90% confidence interval wider, or is the 95% confidence interval wider? So if I were to draw a number line right here, and say I were to put this one, right? I'm going to just mark my numbers down, 136.72 and 145.28. That's the 90%. So now suppose I do it in green and I put the 135. Well, 135.9 is going to be further to the left. And 146.1 is going to be further to the right. So this is my 95% confidence interval, and this is my 90% confidence interval. Which one would you say is wider, the red or the green?
Green.
The green, right? And that's the 95%, right? So we're going to choose A because the 95% confidence interval is wider than the 90. Does that make sense on how we went through that one?
Yes.
Yeah, good. So guys, the one thing I really want to mention, and like I mentioned this before, hold on guys, let me let my cat out because he's ready to go outside. All right, sorry about that, guys. I'm back. So one thing I wanted to mention was in doing this problem here, we could see that doing all of this here, we can do this on our calculator. And that's why I was saying earlier that not that those formulas from chapter 6 and how to do the confidence interval, I don't want to say that they're not helpful. They are helpful. But having the calculator makes these problems, at least the first part of it, that much easier, because I don't have to do a whole lot of calculations. I can just enter those values in, and we can find our confidence intervals, and then we just have to worry about the interpretation part. So anyway, any other questions? That was number 21. Like I said, guys, I'm happy to answer any questions that you have at all. So please don't be shy. Ask me, and I will answer.
How about 25?
25, of course. So let's scroll down to 25. Okay, so 25 says, in a survey of 2015 adults in a recent year, 1,216 have said they've made a New Year's resolution. And it says construct 90% and 95% confidence intervals for the population proportion. Interpret the results and compare the widths of the confidence intervals. Perfect. Okay, so the first thing we're going to do here, guys, we're going to find our value of p hat. Okay, the way we're going to do this is we're going to take the number of adults that we surveyed. In this case, it was 2015. And we're going to look at how many of them said they made a resolution. That was 1216, okay? And I'm going to write this here as a decimal. So I'm going to just take my calculator real quick, like Now I'm going to say, okay, what's 1216 divided by 2015? And I'm coming up with 0.603. I'm going to go to 4 decimal places, guys. I'm going to go to 5. Okay, so 0.6035. Okay, now we're going to do the rest of this the same way. Okay, so let's see. Now let me stop sharing this and let me grab my calculator so I can share that with you all. And let's see, here we go. Okay. Okay, perfect. So now I'm going to go ahead and I'm going to come back to stat. I'm going to go over to tests again, and I'm going to keep scrolling down. Here we go. We have a 1 proportional. Let me just double check this is a 1. Yeah. We're going to use our 1 proportional z-test right here, number 5. Okay. And my P0 is, let me double check. I'm just double checking, guys. Oh, wait, this is not the one. Sorry. Test. Here we go. This should be it. 1 proportion. So it looks like it's part A. There we go. Okay, so here we actually don't need to do, we didn't even need to do that first step. Let's see. My X value in this case, the X value, guys, is going to be what my numerator was, which was the 1216. So I'm going to put 1216. And then my N was the number of people that we surveyed, which was 2015. And we're going to do this first for a 90% confidence interval. So I'm going to just put 0.90. And I'm going to go ahead and calculate. And okay, so I'm coming up with my answers. And on the review sheet, it is asking me to round to 3 decimal places. So I'm going to go ahead and do that. And let me see. 3 decimal places would be 0.586. And the other one is 0.621. Okay. And then we'll go ahead and do that again. So I'm just going to clear this out. I'm going to come back to stat. I'm going to go over to tests. And I'm going to scroll down until I hit that 1 proportion. Here we go. 1 proportion Z interval. And everything is going to stay the same, except now my confidence interval is going to be 0.95. And we will calculate. Okay, so now I'm coming up with 0.582. And so 0.582. And the other one is 0.625. Okay. Let's see. Now, let me stop sharing that and let me share the review with again, you guys. And here we go. And let me just double check that you guys can see that. There we go. Perfect. Okay. So it says with the given confidence, it can be said that and guys, just the way that this thing printed out, these are going to be my choices here for number 1. Okay. So again, before I go on, I want you to look at what we're looking for. We're constructing 90 and 95% confidence intervals for the population proportion. So for number 1, I would say the population proportion of adults that have made a New Year's resolution is, and we're going to say between the endpoints, right? Between the endpoints, because this is the confidence interval, right? And now again, we have to figure out which one is going to be wider, right? So guys, again, if I draw my number line, right, and I'll put these here again in red. So here is 0.586, and here is 0.621. And then I have to figure out when I'm going to put the 582, should the 582 be to the right or the left of this one here? Anybody know? What do y'all think? You think should 0.582 fall to the left or the right of?
Left.
To the left. Very good. Yeah, and guys, and the only reason is because 2 is smaller than 6, right? And the 0.625, it's going to fall to the right because 5 is bigger than 1, right? And so my 95% confidence interval, and here is my 90%. So this is my 90%, and this one here is my, my 95%. So again, we know that the 95% confidence interval is going to be wider. So again, guys, like I said, the one thing I really wanted to mention is that doing this part here, we can do this part here on the calculator, and it's just a matter, and again, I could do it using the formula, and that's, I think when I showed you all how to do it on the notes or the videos, whatever, I showed you how to do the formula, and the formula is great. I mean, it works well, but being able to do this on the calculator just saves that much more time.
So what it was stat and then
I'm sorry, can you say that again?
It was under stat and then test?
Yeah, so yeah, let me show you how to do it again. So I'm going to come back here. Let me pull up the calculator so you guys can see it. Here we go. Okay, if I clear this out, remember before, so I'd go to stat and I would go to test, right? And if I was doing the Z, like the one we did, the number 21, I would do Z interval. But because one is involving proportions, I'm going to do this one here, the one proportion Z interval test. And I believe it's choice A. I'm going to check on my app just to see if it's choice A also. It might be. Like I said, the calculator app, guys, that I use a lot, yeah, it's the same one. It's choice A. And I'm going to see if I can show this to you all. I don't know if you can see or not. And actually, you know what I'll do? I'm going to take a screenshot of it, and I'm going to send it to you on Remind so that you guys can see kind of what I'm talking about. But let me see, let me pull this up. I do want to kind of mention something here. So here we go.
On mine, it's different. Mine's number 5.
Okay. Okay, but do me a favor. Scroll down and go to choice A, and see if it's the same thing.
Choice 8. Choice 8.
A is in like A is in apple.
Well, I don't have 8. I don't have 8. It's either.
If you keep scrolling down, if you hit the little, so like right here, Gilbert, if you hit the down arrow. You see how I'm hitting the up arrow and the down arrow?
Yeah. Okay, yeah. It says 1 dash.
You see it now? That's the one you're looking for.
Okay.
The reason why we're using that one instead of number 5 is because we're doing confidence intervals. Okay, so look, I'm gonna send you guys the message right now, guys, so y'all can see what I'm talking about. And actually, you know what, let me do one more thing. Here we go.
So instead of the test, it's the interval.
Yeah, and I'm gonna send you guys a picture right now, guys, because I want y'all to see what it is I'm looking at. And let's see, here we go. Okay. And so let me save this. Okay, I'm gonna send this to y'all right now in Remind. And let me see, here we go. Here we go, here we go. Here we go, here we go. Okay, so I'm sending it right now. When you guys pull up the picture that I sent you, I put in a red box. I guess I put in the red box numbers like 7 through letter A. I know I kind of did part of B, but we didn't even do B, so we don't have to worry about it. But what I want you to notice about those, it says Z interval, T interval, 2 sample Z interval, 2 sample T interval, 1 proportion Z interval, I want you to notice underneath each of them, it says confidence interval. Y'all see that? On the picture that I just sent y'all to remind?
Yes.
Yes.
Yeah. So that's what and that's, that's kind of one of the nice things about the app compared to the calculator. Is the calculator, I mean, it says there, it says like 2 sample interval, but I have to really understand that that means confidence interval. And when I look at the app, it tells me it's very specific confidence interval. Like it tells me that directly. But anyway, I just wanted to mention that to y'all, and that's how we can do it. And really, the ones that we did were more like 7, 8, and then obviously part A that we just did right now. Those would be the ones that I would be using. And again, guys, whether I'm using my calculator or the app, it's going to be the same type of process. So let me stop sharing this and let me pull up the review again for you guys so y'all can see it. Let's see, here we go. Here we go. Okay, I think you guys can see this now. Excellent. All right, guys, any other questions at all, please let me know.
Could you go over 29?
29?
Yes.
Okay. Okay, perfect. So on here, it says, a company that makes cola drinks states that the mean caffeine content for 12-ounce bottles is 35 milligrams. Okay, I'm going to stop right there. And I'm just going to read this sentence again. I'm just going to try to zoom in a little bit so it looks a little bit clearer. Okay, so look what they're telling me here. It says, a company that makes cola drinks states that the mean caffeine content for 12-ounce bottle of cola is 35 milligrams. Okay, so what that's telling me is that mu is equal to 35 milligrams. This is my claim, right? So now we have to say, what's the opposite of saying something is equal to 35? We would say something is not equal to 35, right?
Right.
Okay. So now that we have that, guys, remember the null is always the one that has the equal to part. So the alternate is going to be the other one.
Yeah.
Okay. So now I'm going to look at my choices A through F, and I'm going to figure out, okay, which one is going to be my answer here. So I want to make sure that my HO has the mu is equal to and the HA is not equal to, and that looks like it would be choice letter E, right?
Yeah.
Okay, perfect. All right, so now we can keep reading the problem. It says we want to test a claim, and during our test, we find that a random sample of 30 12-ounce cola bottles has a mean caffeine content of 36.1. Assume the population is normally distributed and the population's standard deviation is 6.6. At alpha is equal to 0.04, can we reject the company's claim? Okay, so now a couple things I'm going to write here. Next part is we're taking a sample of 30 12-ounce bottles. So that means that my N is 30, okay? And we have a mean caffeine content, so my X bar is 36.1. And our population standard deviation is 6.6. Okay. So now we need to find our critical values, okay? So we're going to find our critical values. Guys, I believe it told us also in this problem that alpha was 0.04. Okay, so the next thing I need to figure out, is this a left tail, a right tail, or a two-tailed text? And the way we determine that is the alternate. Because it says it's not equal to, this is going to be a two-tailed text. Okay. So guys, what I'm going to do here, I'm going to draw a picture. I'm going to draw my normal curve. Okay. And we're going to have our critical values. Now, the way we're going to find our critical values is because since this is a two-tailed test, the alpha value here is actually going to be half of this number. So that's going to be the area underneath that curve, and area over here is going to be 0.02. So we're going to have two critical values here, okay? So the way I'm going to find this here is I'm going to do my inverse norm, okay? And I'm going to find my two critical values. One's going to be positive and one's going to be negative, okay? So we're going to do inverse norm of 0.02. So I'm just going to do this part of my calculator. So I'm going to go second vars. I'm going to scroll down to number 3, which is inverse norm, and I'm going to type in 0.02, and I'm just going to keep hitting enter until I get my answer, which ends up being a negative 2.05, and then this one is going to be a positive 2.05. Okay. So when I get to part B right here, I'm going to choose option B, and I'm going to put 2.05, and notice it already has the little plus and minus 2 here. Okay.
Could you go over
So
the
far,
calculator part again?
yes, of course. You know I will. So let me grab the calculator, guys, so I can show you guys what I was doing. Let's see. Let me get my calculator running. All right, here we go. Boom. Share that with you all. Make sure you can see it. Excellent. Okay, so I'm going to turn this on. Let me turn it on. There we go. Let me clear and get out of here. Okay, so I'm going to go second, and then vars, and I'm going to go down to inverse norm, and I'm going to type in 0.02. Now, I want to mention something. The reason why it was 0.02 is because this was a two-tailed test, and my alpha was 0.04. So what I have to do is, when it's a two-tailed test, I have to take whatever my alpha value is and cut it in half. And then now I'm just going to hit enter. And if you notice, I'm coming up with a negative 2.05. And so remember, I'm going to have two values, right? One's going to be positive, one's going to be negative. So it's giving me the negative value. The positive one will just be positive 2.05. Is that okay so far?
Yes, yes, got
Yeah.
it.
You're good? Okay, excellent. Excellent. So let me stop sharing this, guys, and let me come back to the review itself so we can see what's going on here. My pen on this computer freezes up a lot. Okay, so guys, I want you to notice something. I drew my picture here, right? I drew my picture in green. And just to give you a heads up, these are always the rejection zones, and these are my fail to reject zone. So looking at the picture that we just drew right here, and then looking at this part, which of those options do you think we would pick? What our picture that I drew in the green looks more like which one, A, B, or C?
B.
B.
There you go. Excellent. Good job, guys. Perfect. Okay. Let's. Okay. So now part C. We're going to do part C here, and we're going to find our standardized test statistic. Okay. So the formula here is going to be that x bar minus my mu over sigma over the square root of n. Okay. And so let's see, we had our x bar earlier. It was right here. It was 36.1 minus our mu, which I believe was the 35, right, that we got in part A, all over our sigma, which was 6.6, divided by the square root of n, which was 30. Okay. And guys, I'm going to walk you through the process and how I'm going to do this part here on my calculator, okay? So let me walk you through this part here. I'm going to stop sharing this screen so you can just see how I'm going to do this on my calculator. And let me come back to it. Here we go. Oops, this one here. Okay, so on my calculator, what I'm going to do, I'm just going to clear this. I'm going to put parentheses, guys. So I'm going to go 36.1. 1 Mine is 35. Close that off, divided by, I'm going to do parentheses again. I'm going to go 6.6 divided by the square root of, what was it, 30 in this case. And notice how when I did my square root button on my calculator, it opened up parentheses for me. I think on the 84 it doesn't, but in my case, because it does, I got to close them, and then I got to close the ones from the bottom. And I'm going to hit enter, and I'm coming up with, and I'm going to go, and again, guys, I'm going to go to 2 decimal places, 0.91. So Z is 0.91. So let me stop sharing that part. Let me come back and share the review one more time so you guys can see it. Okay, here's my 0.91. All right. So now I need to figure out, where does this number fall on this number line? So remember, this number here is a negative 2.05. This number here is a positive 2.05. If right in the middle is 0, 0.91 would fall right about there, right? So now my question to you, we fell right about here. Here's my 0.91, right? What region did we fall in?
Fail to reject.
Failed to reject, right? So it says since Z is in the, so A, no. Reject the null hypothesis. Choice B looks like the one we're going to pick. Let's see. Yes, we're going to choose, because Z is not in the rejection region. We're not in the rejection region. We're going to fail to reject the null hypothesis. Okay. All right. So now, guys, this part here, I'm going to pull up my formula sheet again, because I want to mention, again, the one thing I really want to emphasize is that in my formula sheet, that little cheat sheet, I called it my little cheat sheet. I think it's super, super helpful, okay? So we failed to reject the null hypothesis, okay? I'm going to kind of zoom out a little bit. I want to make sure that we understand. Here we go. Right here. Our claim was the null, and we failed to reject the null hypothesis, okay? So my claim is the null, and we failed to reject the null hypothesis. Let me share my, here we go. Let me share this part here with y'all. Okay, our claim was the null. I'm trying to get rid of this little thing here. Here we go. My claim was the null, and we failed to reject the null. So we're going to say there is not enough evidence to reject the claim. That's the statement that I'm looking to write down. There is not enough evidence to reject the claim. So I'm going to stop sharing this. Let me share the review again. And we're going to say there is, oops. There is not enough evidence to reject the claim that a mean caffeine content bottle of 12, I'm sorry, that the mean caffeine content per 12-ounce bottle of cola is, let's see, equal to, right? That's going to be my choice right here, equal to, and wasn't it 35 milligrams? Did that make sense how we're able to do that?
The other one other question I had about this was in that section up there where it says the A and B, the critical value. Why did you choose the positive one?
Let's see. Oh, right here, for right here, this piece?
Yes, that one. Why did you choose? Because I know the Z value is 2.05.
That's right. So, but I want you to notice here, if you look right here in front of it, Gilbert, do you see how it has a plus or minus?
Yes.
So it's already telling me one of the answers is going to be positive and one's going to be negative, right?
Okay.
Do you see what I'm saying?
Wouldn't I be able to write like on the top one, negative 2.05 and still be correct?
Well, but remember, that's what this piece right here means. It means that one of them is positive and one of them is negative. So that minus is telling me that there really are two answers, right? That's why it says the critical values are both positive and negative 2.05.
Okay.
Does that make any sense?
Yeah, that's where I went wrong on that one, because I went with the top one and I put negative 2 point, because mine was 2.58. And it got me wrong on that one.
Okay. Okay. And guys, I want to see, I'm going to just double check something here. I want to show you, how you can, sorry. I want to show you how you can do this on your calculator. And I mean, it's helpful. Let's see. Yep, same numbers. Okay. So I'm going to show you everything that we did here, guys. And I'm going to show you how to do this on the calculator. And okay, so before I go on, remember how we did this part here in the calculator? This is when we use the inverse norm, right? Just so that we said inverse norm, I'm going to try to clean this up a little bit here, guys, so that it's not so messy. I'll tell you what, let me just do this part again. Okay. So we had our graph that looked like this. Okay. Because our alpha was 0.4, but because this was a two-tailed test, we had to put 0.02 here and 0.02 here, right? And we came up with our two critical values, which was a negative 2.05 and a positive 2.05. And if you remember, the way we did that, we just did inverse norm of 0.02, right? And these are rejection areas, and this was our fail to reject area. So I'll show you, so we had already used our calculator to find those values. So look, I'm going to stop sharing this here, but I am going to share my calculator with you because I want you all to see how you can do a lot of what we just did right now on our calculator. Okay, so I'm going to turn it on. I'm going to clear this out. I'm going to hit stat. I'm going to go over to tests. And I'm going to choose a Z test, which is the first one that's in my list. Okay. And we're going to use our stats. So the first thing I'm going to do here, in this particular problem, it told me that my null hypothesis was that the caffeine content was equal to 35. And then I want to say that it told us our standard deviation was something like 6.6. And I want to say that our N was 36.1. We had those 30 cans of soda, and they found that the average was 36.1 milligrams. And they had, how many cans of soda was it? Wasn't it 30?
30.
Yeah. And then we said this was a two-tailed test. So I'm going to leave this here on the not equal to part. And I'm going to go over to calculate. And I'm going to hit enter. And I want you to notice what we came up with. Look at the Z value here. Isn't that Z value the 0.91? Wasn't that the same number that we came up with when we did our problem? So if you look here, I came up with a 0.91. And if I share the review again one more time with you all, here's my 0.91, right? There we go. The only thing that little feature or whatever I want to call it on the calculator, really what that did for me, it did that calculation. So last fall when I taught this class, the question that I asked my students in class was going through that little exercise on the calculator, was it helpful? And some people said, oh yeah, it was super helpful for me. And I had other people say, no, because I can do this part. This part wasn't difficult for me to do. But it really was up to the individual on, was it hard for them? Was it super helpful, and was it not? So, and I forgot to write my answer right here. This was the 0.91. But I'm going to leave that up to you guys to decide whether or not that part is helpful for you, okay? And when I did these videos, guys, I walked you all through this whole process because I wanted you to see the steps that I needed to do to get there, and then I can, using that little, I call it the cheat sheet, using that little cheat sheet, I could determine, what my answer was going to be. How was I going to base my answer, given the results that we got. So anyway, I just kind of wanted to give you all a heads up on that. And if that's something that you want to use, you're more than welcome to use it. And if doing this little calculation right here in the middle, doing this part right here was not a big deal, then you don't need to worry about that part. Good, good, good. Guys, any other questions here on the review? That was number 29. Anything?
Can we do 32?
32, of course.
Thank you.
Yes, ma'am. Definitely. Okay. So now let's take a look at 32. Number 32 says, a research center claims that at least 30% of adults in a certain country think that their taxes will be audited. Okay, so I'm going to read this part right here. Okay, a research center claimed that at least 30% of adults in a certain country thinks that their tax will be audited. Okay, so we're talking about a proportion, a percent, and at least 30%. What do y'all think at least 30% means? Does it mean 30% or more? Does it mean more than 30%? Does it mean less than 30%? Anyone have an idea? What do y'all think?
Greater than or equal?
Yeah, greater than or equal to. Excellent. Greater than or equal to. So P is going to be bigger than or equal to 0.30. Okay? This is our claim. Okay. So guys, the opposite of saying P is bigger than or equal to 30 would be P is less than 0.30. Okay? Now we need to figure out which is our null and which is our alternate. So the null always has the equal to part. And so this is going to be my alternate. Okay? All right. Okay, so now it says identify the claim and state the HO and the HA. Okay, so it says the percentage of adults who think that their taxes will not be audited is, no, here we go. It looks like it's going to be choice D, at least 30% of adults thinks that their tax will be audited. Okay, so now that we wrote this one here, we're going to just go ahead and fill that in. So it looks like we'll choose option A. So choice A here, this is going to be 0.30 here and 0.30 there, because that's exactly what we have in these parts. Okay. All right. Now it says, in a random sample of 1,200 adults in a country in a recent year, 27% say they're concerned that their taxes will be audited. At alpha is equal to 0.10, is there enough evidence to reject the center's claim? And compute parts A through E below. Okay, so let's go ahead and draw a picture. So here's my picture. And now I got to figure out, I shouldn't draw that little line too soon. I need to figure out, is this a left tail, right tail, excuse me, or two tail test? So remember, the way we determine that, guys, we always look at the HA. And because it's pointing to the left, this is going to be a left tail test. And this is going to be my alpha value here, and an alpha is 0.10. Okay. So we need to find that critical value. Okay. So remember, I'm going to do this just like we did before. I'm going to find, let's see, I'm going to find inverse norm of 0.10, okay? So let's see if we can do that. So guys, I'm just going to take my calculator again. I'm going to go second bars, inverse norm. I'm going to type in 0.10. And let's see. I am coming up with a negative 1.28 here. So right here, I'm going to write negative 1.28. So far, are we okay with that part?
Yep.
Yeah, we're good? Okay, so guys, again, just a reminder, this is my rejection region, and that's my fail to reject region. Okay, so now, let's see. Now it's asking me here, where's my rejection region? Choice A, B, C, or D? Since we're looking to the left of negative 1.28, we're going to choose D, to the left of negative 1.28. That's my rejection region. Okay. Now we're going to go ahead and find our Z value. Okay. So guys, I'm going to stop sharing this and I'm going to pull up my formula sheet because I want y'all to be able to see how am I going to find my Z value. Okay. So let me stop sharing this. Let me get my formula sheet for you all. Here we go. Okay, so I think you guys can see my formula sheet. And let's see, I believe this is it right here. This is going to be my formula for finding my Z value, okay? So I'm just going to write that down on the actual thing itself so that I can go back and reference it as I need to. What is it? P hat minus P. P hat minus P all over the square root of PQ over N. Okay, so let me stop sharing the formula sheet and let me share the review one more time so y'all can see it. Okay. Okay, so guys, coming back to my problem, my P hat is going to be the 0.27, okay? My P was already the 0.30, okay? So there's a couple things that we need in this formula. We need P hat, which is 0.27. We need P, which is 0.30. We need P and Q. So if P is 0.30, does anybody know what Q would be? So
One less than 30?
I'm sorry, it would be what again?
One less than 30, so 29?
Right, less than 30, that's right. It would be 0.70. So think about it this way. If Tim Smith says, hey, there's a 30% chance of rain on Saturday, that means that there's a 70% chance that it won't rain. Excellent. Good. So this is 0.70. And then our N is right up here. It told us that there were 1,200 adults. Okay. So we're going to find our Z value. So guys, I'm going to pull up my calculator so you can see exactly how I'm going to enter this in. And you guys let me know if it makes sense. So let me stop sharing this. Let me pull up the calculator so you can see it. And here we go. And let's see there and here. Okay. So on my calculator, let me turn it on. Let me clear all this out. I'm going to use parentheses, guys, because it makes it much easier for me. So 0.27 minus 0.30 divided by, now I'm going to have a square root. It's a big square root. Square root of 0.30 times 0.70 over 1,200. Close my parentheses and hit enter. And here I'm coming up with a negative 2.27. So negative 2.27. Okay. And so right here, I'm going to write negative 2.27. Let me stop sharing that with you and let me share my review. And let's see, yeah, you guys can see it. So guys, all I did right here is I just wrote in negative 2.27. Okay, now I'm going to look at my picture again. So I'm looking at this picture right here, and I need to figure out where would the number negative 2.27 fall on this number line. Do you think it would fall in the rejection region or in the failed to reject region? What do y'all think? Compared to this number right here, where would negative 2.27 fall? Would it fall to the left of that number or to the right of that number?
To the right, be failed to reject.
But look, it's a negative 2.27.
Oh, yeah.
Right? So wouldn't negative 2.27?
It's further down. It's further down.
Yeah, it'd fall right there, right? So this is going to be our rejection region, right, guys? Now, okay, so now part D says, okay, so again, it's giving me some options. And it says, interpret decide whether to reject or fail to reject the null hypothesis and interpret the decision of the, okay, so number one, we're going to reject the null hypothesis. So right here, we're going to say, we're going to reject the null hypothesis. Now, guys, I need to figure out how am I going to answer this part here. So again, one more time, I'm going to stop sharing this with you, and I'm going to share my cheat sheet because that has all the information that I'm going to need on how to determine that. So I'm going to come back over here. Okay. Here. I need to go back and I'm going to look at my problem again. Was my claim the null or was my claim the alternate? When I look at my problem, our claim was the null, wasn't it?
No.
Yeah, our claim was the null. Yeah, our claim was the null. And we rejected that, right? So when I look at my cheat sheet says if my claim is the null, right, and we rejected it, then we're going to say there is enough evidence to reject the claim. So again, I'm looking at this part right there. There is enough evidence to reject the claim. So let me stop sharing this. Let me share the review one more time. And we said there is enough evidence to reject the claim. There is, we'll choose this part, enough evidence to reject the sender's claim.
Yeah.
All right. So this one here, that was number 32. That was number 32. Any other questions you guys have, guys? Please let me know, because you know I'm happy to answer them.
I think I'm good. I'm good with that.
You're good?
Yeah.
Give me 1 second. Let me see. So, Laura or Maribel, do y'all have any other questions you wanted to ask me? Anything? So guys, we did have one other student in here. Giselle had a couple of questions. She had to log off, but she did send me a message asking me if we could do 26, 28, 32, which we did in 35. So if you guys are okay with it, I want to do those problems just to make sure that Giselle is good. And then I'll upload the video. So if, let me see, somebody sent me a message. Okay, Laura, I just saw your message right now about what happens when overlap. I'm not sure what problem you were talking about. Do you know which one you were referring to?
And the homework, some of them were some of them, there was one that it was slightly overlap, but to the side. So I couldn't clearly see outside or inside, parentheses wise like that. It was slightly over to a side, but it would overlap partial of the answer.
When you say overlap, are you referring to like the rejection and the fail to reject region? Or are you talking about the confidence intervals?
The intervals.
Okay, so remember on the intervals, so good question. Let me do it like this so you can see. Okay, so I think you guys can see this here. So here's my number line, right? And I'm just going to make up some numbers. I don't know what they're going to be, but I'll write this as 12.8 and I don't know, 17.9. And then I'll do another one where, say, one of the numbers is 11.3 and it's going to be something like 19.2. So every one of my confidence intervals should look, when I'm doing that, you know, which one is wider, every one of my confidence intervals should look something like what we just drew right here. They should all look something like that. And guys, think about it this way. The bigger the percentage, so if you have a 90%, a 95%, and say even a 99%, the one that's going to be wider is going to be this one. The bigger the confidence interval, the bigger the percentage, the wider it will be. Okay, so so I hope that answers your question. But anytime it's asking you to choose between two confidence intervals, whichever one has the bigger percentage, that's always going to be the wider confidence interval. Okay. So I hope that answered your question. Guys, let me do those other.
Thank you.
I'm sorry?
Yes, I guess I must have done something wrong because it wasn't coming out exactly like that. It was kind of one over the other, and I was confused. So yeah, if it doesn't look like that, then I did something wrong.
Okay, and then the other thing I would recommend, Lana, remember how we did it on the calculator? And I don't know, are you using the calculator or are you using the app? Do you remember?
The app.
Okay, so I think I had sent out a video last week that somebody had asked about some of the problems. So using the app, use that confidence interval, and the only thing it'll do, the only thing is different when you do the app, it tells you like lower and upper, and lower is always going to be the first one, and upper is always going to be the second one. But try using the app, and that's probably all you really need to do. And I'm sure it could have just been something minor, but just double check it, and I think it'll work out. But again, if you got a question, let me know. I'm happy to help you out. So guys, let me do that. Let me go over those. Let me go over let's see, those couple of problems that Giselle had. And guys, I'll do those. And then if there's another question that any of you still had, then we can definitely go over those. I think it was just 3 that she wanted me to do because we did one of them right now. So she said 26 and 28. So we did 29. Okay, let's do 26 first. Oops, here it is. Okay, so 26, and we did one very similar to this right now. And actually, Laura, this is a good question because this is actually doing the whole confidence interval business. So let's see. It says in a survey of 2,058 adults, 732 made a New Year's resolution to eat healthier. Construct 90 and 95% confidence intervals. Okay, so now we'll get a chance to use the calculator or the app. So guys, the one thing I'm going to do here, I'm going to write my numbers. My X, oops, not my X bar, but just my X. My X number is the number of people who made the resolution. The N is the number of people who we surveyed, which was 2058. And we're going to do this twice. We're going to do this once with a 90% and once with a 95%. Okay, so let me show you how to do this on the calculator. I'll stop sharing this here, and I will share the calculator so you guys can see how to do this. And again, guys, whether you're using the calculator or the app, the process is still going to be the same. Okay, so let me turn this on. I'm going to go to Stat. I'm going to scroll over to Tests. And remember, guys, because I'm doing with proportions, this is going to be choice A. one more right here. The one proportion Z interval. So I'm going to hit enter here. And my X number in this case was 732. So I'm going to put 732. My N number here was a 2058. And then my confidence interval, so I'm going to do this twice. The first time I'll do 90%. So 0.90. And then I'll go to calculate. And like I said, Laura, when you do this on the calculator, it is going to give you two numbers. It'll say lower and upper. And on yours, the lower should be the 0.33833, and the upper should be the 0.37304. So let's see. It's asking me to round to 3 decimal places, so 0.388. Give me 1 second, guys. 0.338. And the other one is 0.373. And then we'll do this process all over again. So I'll go to stat, I'll go to tests, and I'll scroll down till I hit choice A as in apple. And everything is going to stay the same except for my confidence level, which is going to be 0.95. And we'll calculate. And so now I'm coming up with 0.335 and 0.376. There we go. Okay, stop sharing the calculator with you and let me share the review again. And so I just put my numbers in right here. Okay, and it says with given confidence, it can be said that, now again, remember, we're going to choose from, are we looking for sample proportion or population proportion? It tells me right here. Yeah, we're looking for the population proportion. So we're going to say the population proportion who made resolutions to eat intervals, eat healthier is between the endpoints, right? Between the endpoints. And then which one is wider? Remember what we said, guys. The bigger the confidence, that's the one that's going to be wider. Right? Okay, so Giselle wanted 26. We just did it. She asked for 28, which is right here. And we can do this too. This one's going to be straightforward, and it's just telling us, you know, what are we looking for here? It says a laptop manufacturer claims that the mean life of the battery of a certain model laptop is more than 8 hours. Okay, so when I read this part here, it's telling me that mu is more 8. This is our claim, right? Okay, so guys, let me ask you a question. What is the opposite of saying something is bigger than 8?
Less than or equal to?
Less than or equal to. Excellent. Okay, so now remember, this is my null, and that's my alternate. The null always has the equal to part. Okay, so the first part says, write the claim as a mathematical statement. Here was our claim. So we choose E, okay? And then choose the correct null and alternate hypothesis. So the null has to have the less than or equal to, and the claim has to have the greater than. So let's see. I guess choice D as in dog. Looks like the right choice there. Okay. And now it's saying, which is the claim? So the claim was the alternate, and the alternate said that it was greater than. So we're going to choose part E. The alternative hypothesis is the claim.
Yeah.
Right? And let's see. And I guess that's all it was asking us to do.
Yeah.
We didn't even have to do the whole problem. It was just like steps of a problem. Excellent. Very good. Okay, so I think there was one more she wanted me to go over. That was, we said 26, 28. We just did 32, and she had asked for 35. So let me scroll down and see if I can find 35. 35. Pass it. No, here we go. Okay. So let's take a look here. 35 says you want to buy a washing machine, and a salesperson tells you that the mean repair costs for Model A and Model B are equal. Okay, so it says you research the repair costs, and the mean repair cost of 28 Model A washing machines is 210. And assume the population standard deviation is 20. The mean repair cost of 24 Model B washing machines is 227. Assume the population standard deviation is 23. And an alpha is equal to 0.01. Can you reject the salesperson's claims? Assume the samples are random, independent, populations are normally distributed. Let's see. Complete parts A through E. Okay, so it says identify the claim, state the null, and the alternate. Okay, so when I read this first sentence right here, guys. Okay, it says that the mean repair costs from Model A and Model B are equal. So we're going to choose option D. Okay, the mean repair costs for Model A and Model B are equal. Okay, now it says let mu1 be the mean repair costs for Model A and mu2. What are HO and HA? Okay, so mu1 is equal to mu2, right? This is our claim. So the opposite of saying something is equal is saying that it is not equal to. So isn't this going to be my null? And won't this one here be my alternate? So now, when I have this part right here, we're going to come back and we're going to look at the second part and we're going to say, okay, which one are we going to choose from here? So it looks like we're going to choose option D, as in dog. Okay. Now, the next piece, guys, we need to figure out, is this a left tail, right tail, or two-tail test? So remember, the way we determine that, we look at the HA.
Two-tailed test.
Yeah, two-tailed test, right? Excellent. Okay, a two-tailed test. And if my alpha is 0.01, I need to take that number, 0.01, and divide it by 2, which should be 0.005. Okay. So 0.005 here and 0.005 there. Okay. So we're going to find those critical values, right? So guys, remember how I'm going to find my critical values? I'm going to use my inverse norm, right? So let me just do that here real quick. Second bars, I'm going to go to inverse norm of 0.005. And I'm coming up with a negative 2.58. And this is a positive 2.58. Okay. So when I look at choice B, what are the values? We came up with two of them. One is a negative 2.58, and the other one is a positive 2.58. So the only difference in this problem and the one that Gilbert asked me a little while ago was when it gave me that to do that part B or whatever it was, it gave me an option, and one of them was plus or minus. So I chose that one, right? If this one would have had a plus or minus, I would have done the same thing. Okay. Now, guys, just to give you a heads up, remember, these are my rejection regions, and this is my fail to reject region. Okay. So the rejection regions is going to be when we are smaller than 2.58 and bigger than 2.58. So this is going to be less than negative 2.58. Excuse me, and bigger than 2.58. Okay. All right. Now, we're going to do part C, and this is when I'm going to use my calculator, guys. Okay. So I'm going to use the information that is here to do this, okay? So I'll put it this way. We have model A, we have model B. For model A, the number of them is 28. And the repair cost, my X bar was 210. And my population standard deviation was 20. For model B, we had a total of 24 of them. Our X bar was 227, and our population standard deviation was 23. Okay, so guys, I'm going to use this information here to answer this part. Okay, so let me stop sharing this and let me share the calculator so you all can see how I'm going to do this. Pardon me. Okay. All right, so I'm going to turn it on. I'm going to go to stat. I'm going to go over to tests. And I'm going to go over to a 2 sample Z test. And let's see, here we go. We're going to go to stats. Okay. Pardon me. Oops. So my sigma 1 is going to be 20. My sigma 2 was 23. My X1 was 210. And my N1 was 28. Pardon me. My X2 was 227. And my N2 was 24. And this was a two-tailed test, so I'm going to leave it right here on the not equal to part. And I'm going to go ahead and I'm going to hit calculate. And we're coming up with a z-value of negative 2.82. Okay, so I'm going to stop sharing this here. Let me share the review again. And in doing that part here, we came up with a z-value of negative 2.82. Okay. So now I need to figure out where would this number, where would that 2.82, negative 2.82, where is that going to fall on my number line? Am I going to fall in my reject region, or am I going to fall in my fail to reject region? What do you guys think? So this here was, oops, this number here was negative 2.82. So guys, I'm going to fall over here. We're falling in our rejection region. So we are rejecting the null hypothesis, right? Okay. And now, when we get to the next part here, let's see, what was our claim? I already forgot what our claim was. Our claim was the null, right? And we rejected it. So let me stop sharing this so I can share the cheat sheet with you guys one more time. All right, here we go. So my claim was the null, and we rejected it. So we're going to say there is enough evidence to reject the claim. So here we go. And at, what was our alpha level? Our alpha level was like 0.01. There is enough evidence to reject the claim that the mean repair costs for model A are equal to the mean repair costs for model B. And that's 35. All right, guys, did y'all have any other questions? Y'all feel okay?
Yeah, I'm good.
I'm good, thank you.
Okay, so let me see. Stop sharing this. Okay. All right, then, guys. I am going to upload this. At any point in time, guys, if y'all have any questions about anything, send me a message. I usually don't respond on Sundays, but if you got questions tomorrow, Saturday, let me know, and I'll get back with you guys. And guys, next week's going to be a little rough because I have 4 different courses, and just like I'm giving you guys 2 options or 2 time slots for the test, I'm doing that for every one of my classes. So Monday through Thursday, I'm testing twice a day in all of my classes. So like you guys are taking it Monday night, Tuesday morning. Another class is taking it Monday morning, Tuesday night, Wednesday morning, Thursday, that kind of thing, right? So I'll be a little busy during the week. Once you're done with your final, I'm probably going to just do all the grades next Friday. But for us, it's going to be pretty straightforward because, I mean, we've pretty much done everything. I'm going to try to start looking at those class assignment number 2 things. You know, if I don't get a chance to look at them tomorrow, I'll be doing that next Friday. But my goal is next Friday is to be done with everything. And what I'll do is I'll send you guys a message and I'll say, hey, go to my math lab and double check on your overall grade, and everything should be up there. Like I said, guys, I have opened up all the homework assignments. I went ahead and opened up all the quizzes. If there was any quiz that you weren't happy with, excuse me, you know that you can do it again. I put a total of 5 attempts, and I always take the best of the grades. So, you know, there's no reason why you really can't make 100 on everything, you know. And, guys, I appreciate everything. Y'all did really well this semester. Y'all were one of my better classes. It was you guys in a math for teachers group that you guys were the best groups. So I appreciate everything. You guys had great questions. I'm glad I got to know you all on a limited basis. It would have been much better if I would have been able to see you twice a week, but you know, we're doing what we can. So anyway, that's pretty much it for us tonight. If you got questions about anything, let me know, and you know I'm happy to help you guys out. Okay.
How many questions are we looking at for the test?
I think it's 14 or 15.
Okay.
And let me double check, and I'll tell you right now. Let's see. Let's see. Here we go.
They're all coming out of the review guide?
They're coming directly out of the review. See, 14 questions, Gilbert, and they came directly from the review. Nothing is changed at all. I mean, the only thing that's going to change are the values a little bit here and there, but the process is exactly the same.
Sounds good.
Okay. All right, guys.
Thank you. Good night.
Of course, if there's anything you need, you know, let me know. I'm happy to help you. Okay.
All right. Appreciate your help.
You guys stay safe. Okay.